Yeah, we'll start soon, but let me just put this screen. Yes. Uh, yes. Soon, but let me just hello. Let me just test my mic. Yeah, this is a very. Let me. Yeah, hello. Yeah, this is better. So, yeah, I think so. Am I? Wait, where the fuck is this? Yeah, yeah. Now this is better, I guess. Okay, so main thing is that I'm going to randomly solve because tomorrow is my interview. So I don't know. Can I write with this? How do I write? I think got it. Yeah, so I can type like this, I guess. Okay. So I hope everybody can see this. Okay. So so give me like 2 minutes. I need to also see the stream chat, I guess. I don't think anybody is seeing the thing, so might be just myself talking to myself, but I'll start. So, explain supervised, unsupervised, weekly, uh, weekly supervised, semi-supervised, and active learning. So supervised is basically when you have like labels, like for example, when you have cat, dog as labels, and you're like, for example, let's say you have some image and you're labeling it as cat and dog. This is cat, this will be dog. So like you have like some labels when you predict the y. Okay, so like some f of x, then you predict the y, and maybe and unsupervised is, for example, let's say there's a graph like this. Some points are here, some points are here, and they're not labeled. Okay, so you kind of make a decision boundary, not decision boundary per se, like you cluster them into, this might be the cats, this might be the dogs. I think this is a suitable answer. Weekly supervised means, I guess, I don't remember this correctly. If I'm not wrong, weekly supervised means, how do I call it? Weekly supervised can mean, the labels are not good. Like this, let's say this label does not exist. So basically, some mix of like noisy data, I guess. I think so that, let me weekly supervised. I think so that is the thing. Like let me machine learning approach with partially noisy data. That is what it means. Okay. I hope so. My voice is visible. Hello, SK Dati. Okay, so next is semi-supervised. Semi-supervised is small, like small labeled set with many unlabeled samples. So for example, if you have like medical images, I guess, like so let's say 100 are supervised and 10k are unsupervised. So that is like semi-supervised. Okay. An active mm, active learning is something like, I think, like used in emails as well. Like when you're having a spam classifier, you get the labels only for the emails that are near the decision boundary. I think that is what you can say. Okay, so I is there an option to clear everything, bro? Wait. I'm very new to using this. Okay, so I think this does it. Yeah, this deletes everything. Good, good, good. Okay. Empirical risk. I don't think these questions will come. Risk. It's basic. Risk minimization is something like you try to minimize the average loss on your training data set. I think that is the yeah, that is the meaning. Like I don't remember it that much in detail. So yeah, this thing won't come in a SD interview that much. Occam's razor. So yeah, Occam's razor is, I think, how do we explain this? Like I feel like you'll avoid overfitting. For example, let's say if you have a model with, let's say, 10k layers, and that gives like 40% accuracy, and I have like a 10 layer thing, it also gives 40%. So yeah, I think if you use the 10 layer thing, there will be less overfitting. Okay. What are the conditions that allow deep? This is a historical question. What is this? You have a wide NN and a deep NN, which is more expressive, and why? Okay, so wide and deep is simple. Like I think more layers you'll learn more features, right? If you have, I think this will be more like the deeper one will be the better one for expressiveness, because more layers, like if you can have like one big layer or like three small layers, for example, right? So I think with each layer you get a different, more expressive feature as compared to a big layer. Okay, I feel that is the case. Okay. Oh, let me clear this. I cannot read the next question. Neural network with one hidden layer. This simple layer are really small positive. I'm not sure about the next one, to be honest. Let me. I'm not sure. We'll come back to this. I'm not sure about that. What are saddle points and local minima? As simple as that. Let's say there is a graph like this. Very shitty graph to be drawing. Like say this. So this will be the local minima. So local minima is basically this point is a minima with respect to the local in this locality, right? But this is not the global minima. This is not the minimum value you can achieve. This is the global minima. So that is the local minima. What are saddle points? Saddle points is like, let me check the chat, I guess, if anybody, yeah, nobody has said anything. So I think so, like, yeah, have you even seen that Pringles diagram? I don't know. Pringles diagram. Yeah. So this is a saddle point. Yeah. So like this point is like a saddle point. So this is a minima here, as you can see, but there are more minimum. Like in this case, you get dy by dx as equal to 0, but this is neither the maximum point nor the minimum point. The maximum point would be something like here, the minimum point would be somewhere like here, right? So even though the dy by dx is equal to 0, it is neither the maxima nor the minima. Okay, so this is a very good diagram, I guess. Which are thought to cause more problems? Mm, both will have gradient 0, but I feel like the normal local minima will not give that much of a problem, but saddle points. I don't know. This answer can be anything, to be honest. Like there can be one case where, let's say, this is the global minima and this is the local minima right here, right? For example, this can be the case, but saddle point also. Yeah, I think minima has the thing to go as deep as possible below. I have no idea about this question. Which I think this will be case to case. We cannot say which one will be the case. Okay, so what is the difference between hyperparameters? Parameters are like learned from data. Hyperparameters are some values, I think, which you will fix before the training. You won't change it over the training. You can do hyperparameter tuning. That is the thing. So for example, linear regression, you have linear regression. The weights in the linear regression are the parameters, and the alpha, for example. So the gradient descent, not in, like, for example, gradient descent, you're doing this alpha dl by d omega. This is the hyperparameter. Okay, so you fix this alpha while training, right? Not going, you can change it. There are linear schedulers, you can change it. It's not a problem. Convergence will be the problem, I feel, going from maxima to minima. Fair point. I think this question can be solved. This question is like very open to interpretation. It can be both of them, is what I feel. The differences between, what is hyperparameter tuning? Again, the hyperparameter tuning is something you don't know which value of alpha is best, so you should decrease some. So if you're seeing, let's say if you have a validation set, right? So if you have a validation set, you see the accuracy is increasing with, let's say, alpha equal to 0.1. And then you see it starts dipping a bit. Okay, what you do, you bump it up a bit, 0.011. Sorry, 0.11. Does it increase? If it decreases, no, I'm going in the wrong direction. Let me do 0.09. No, it starts increasing. So this is a good approach. So this is how you can find kind of the best hyperparameter, is what I feel like. So that is why it's important. An algorithm, like you can do randomly as well. Like there's something called random search, if I'm not wrong. So, and these are all, so algorithm specifically I cannot say that, but like there are specific optimization problems. So these are all optimization problems for the hyperparameters. So we do have to do that. Okay, let me delete all. How do I delete this, bro? Yes, deleted. Okay, so next question is classification versus regression. Classification, again, discrete outputs like yes or no kind of thing, and or like is it this or that. Regression is like continuous output. So for example, regression is, for example, let's say if I have these points, the linear regression would be like a line, right? For every point there will be some value, right? But let's say if there is an image, you can either say it's a cat or a dog. So this is a classification problem, this is a regression problem. Okay, can a classification problem be turned into a regression? Yeah, you can, but like again you change the problem thing. Okay, so for example, so logistic regression, for example, logistic regression is one case where I think logistic regression is like regression, and you have this regression. Now let's say the sigmoid function turns out to be something like this, right? So now let's say this becomes this is, by the way, managed. So like let's actually sigmoid looks like something like this. Okay, so this is the 0.5. Let's say if it is greater than 0.5, I say it's yes. If it is less than 0.5, then it is a no. So this, see, you get a regression problem, convert a regression problem into classification problem. So yeah, again, you just have to change the problem statement or like put a threshold, is what I feel like. Okay, let me check if did anybody say anything. Like we have 4 viewers. Nice. Yeah, saddle point is horse kinda. Yeah, that is where the name has come from. Parametric is like fixed parameters, and non-parametric is as the data size, matlab, as in like the data size and the model complexity is somewhat related, right? So for example, if you have more data, it gets you better boundary, something like that. And parametric is better for a very small amount of data. Like for example, if you have like 100 data points, maybe parametric would be better. Non-parametric is like I don't have any like for example, people with fractures, for example, people have lots of fractures, right? So you'll have a lot of fractured data. Why does ensampling independent training models improve? Mm-mm-mm. I think it's more of like, if let's say if I have one model here, M1 and M2, it has its own bias or slash variance, like slash shit nature. Okay, each of them both have. So averaging these both out lower this value is what I feel like. So that is why ensembling helps a lot. Why does L1 lead to sparsity and L2 lead to weights being zero? Um, Wait, let me check this. I'm not sure about this. So, I'm not sure about this. I have not done theory in so long. Well, came from here from Twitter. Hello, welcome. Can you repeat the solution for 9b? Yeah, so basically, let's say logistic regression is something like this. You'll get a final sigmoid, right? So this is a regression problem because you're having some values for every x, you'll have some value of y, right? But here, let's say this is 0.5, this value is usually 0.5. I say if the value is greater than 0.5, it will be a yes. If value is less than 0.5, it will be a no. So this becomes classification problem, right? So if you change the problem statement of regression, it might turn into a classification problem and so on. Like you can do the reverse thing as well. So if the problem is like this, if I remove this threshold, then it becomes a regression problem. Okay, L1 regulation, this I have to check again. This one I also am not sure. So yeah, things I have to check. I'll check it later. Why does ML model perform degradation in production? I think in production they give you distilled models. No, I don't know. So basically because you cannot load like the whole model there, so they usually prune some layers, they distill the model, they even can give you quant models as well, right? So that is the thing. Yeah, same thing here, the same thing in this one. Your is performs well on the test set but poorly in production. See, this production issues is, I don't think this will come, but again I think production has some quantized models or distilled models or pruned models. Some kind of shit has been done. Okay, that is the thing. I think, how do you validate the hypothesis is correct? Basically get like few math, like 5 math question, I guess 5 coding question, and see the reasoning traces for this is reasoning traces for that. Okay, and if you see that the reasoning is much shit, right? Like for example, a 1 billion model, and let's say, so this is a distilled model from, let's say, a 405 billion model. Okay, so the reasoning trace for this will be very much detailed. A smaller model usually will do this, is that it will finally, it can solve the question maybe. In the correct answer, what it will do, it will tell ki, okay, this is the reasoning, this is the correct reasoning, and it will doubt itself. It will have like a section of doubt in the middle, then again come back to the correct answer. So this is like a very good way to find like if the model has been distilled or not. So you can just test this out on, like, this is Qwen, let's say if you have Qwen 32 B does not do this, not Qwen 32, yeah, DeepSeek 716B wala model. If you run it, you will see it has a very good thing, but the 1 billion distill into Qwen does this thing I have just told you right now. Okay, yeah, latency, like, again, this is a very open question, like all many answers. I cannot read the last question. Can you just, yeah, imagine the hypotheses are correct, what would you do to address them? Maybe post train them better. Like, see, this thing has been direct distilled, right? So I don't think there has been post training on this. Put some good amount of SFT into this on some good instruction set instruction set data sets. I think that is more than enough. Okay. I think this page is done. Let's go to the next one. I think I have to select pointer. Okay, I think this is all about, this is all mathematical. I don't think mathematical stuff will come tomorrow, so I will not do mathematical stuff. This is 75 question, 17 questions, sorry. This is 17 questions, so let's try to do this. I will not do CV because I have zero idea about CV. Let me see the questions. Cancel. What's the problem? I'll leave it. This is questions, not questions. Okay, this is questions. NLP, yes, I'll answer the NLP questions. RL also, I guess. No, I can't do RL that much. Maybe you can. Computer vision, I have very less idea. Okay, this thing, maybe like few answers I can do. Other also I can do. Training as well, a bit I guess I can do. Where were we? This objective functions, no? Yeah. एग्जाम कब से है? नेक्स्ट वीक से है. मेरा कल इंटरव्यू है, दैट्स व्हाई आई एम डूइंग दिस. सो I'm doing interview prep after so long. This is like 1 year after I'm doing this. Okay, so where is the pen? Okay, so when we say, what do we say when a algorithm converges? So what can you mean when it converges? Basically, let's say that loss diagram will look something like loss diagram, so if you have seen the loss diagram, it looks like something like this, and it goes to a very flattened state. I think this is what you mean when an algorithm converges, as in the values of the loss will basically the things you are checking, right? Loss, anything, will stop changing much. Okay, like you can also see the gradients will approach zero and everything. Yeah, so how do we know a model has converged? This is the loss graph. As you can see, if you see the loss graph is something like this, then you know that, yeah, so if the loss graph is something like this, you know it is converging. So usually, like, we also stop up when we see these things. And also on the validation, we can also do the validation check. Like, for example, let's say the accuracy grows like this, and it flattens, right? This is on the validation set, and we know this is not increasing that much. So let's say if we have something like delta of change is less than epsilon for, let's say, for all I plus 1 till, let's say, some I plus k, as in, like, to some extent we see there is very minimal change, then we stop it. This thing is called early stopping. Okay, this is how we know the model has converged to some extent. Okay, draw the loss curves for underfitting, overfitting. Wait, I have forgotten the loss curves. Okay, so let me check this loss curves for underfit. Yeah, like, the main logic leave. The main logic I'll tell you, as simple as that. In overfitting, what will happen? You'll see the accuracy will grow like this. Accuracy will grow. This is for the train set. For test set, the accuracy will be very low. Okay, and for underfitting as well, you'll see the training is not done completely. Test set also is shit. Okay, and for normal case, it will be normal, nothing different, to be honest. So let's see the curves. Yeah, loss increases for validation. Yeah, loss will increase. Underfitting, it will be much lower. Yeah, so of course, yeah, so my bad. So for this is for the This is for underfitting. So underfitting, usually the loss curve is something like this, right? So instead of that, it will be something like this. This is train and this is validation. For overfitting, the train curve will be something like this. The validation will be something like this, I guess. Okay. And for normal case, it will be close to each other. Not much difference. Okay. So yeah, I think this is good enough as an answer. Where is bias? Again, so bias is like error due to the model's assumptions. So for example, the model is very simple, it cannot capture the patterns, and variance is basically training data has so much noise it will grow very sensitive. So basically overfitting happens usually during variance, high variance, and high bias gives you underfitting. Okay, so underfitting is high bias and overfitting is high variance. So these are all trade-offs. Okay, so basically if you have high bias, means what? You cannot fit a pattern well, right? You cannot fit a pattern well, that means it's underfitting, so the variance will be low. And in the case of overfitting, you fit a pattern so well, the variance will be very high. With the test set as well, the variance will be very high, so but bias will be low because you can fit nature really well. Okay, how to detect is, I think, what I just told. Yeah, 3 and 4 is basically what I have told. Cross validation. I think I can explain the k-fold k-fold thing. I think it was something like this, right? There is the whole data set, so you break it into parts, let's say 5 parts, the 1, 2, 3, 4, 5. Maybe this is the training one, this is for validation, and yeah, so for example you split it into k-folds, and yeah, so you do this, but you do shuffle this. Okay, so for example, one time 1 will be validation set, one time 2 will be validation set, 3 will be validation set. Yeah, that is k-fold, I guess. I don't remember that much. Okay, these are very like theoretical questions and I have not read that much theory in over an year, I guess. Okay, why don't we see most cross validation in deep learning? You're wasting time. No, again, you're like, for example, usually like let's say if you're trailing an LLM, it takes you 2 months, right? In a normal case. So if you have to do cross validation, let's say if you even keep 8 k folds, right? So that will be 16 months of training. I don't think anybody can afford that. So I think that is the reason. What's wrong with training? Yeah, of course, the unethical, man. What is this? What is wrong with training and testing a model on that same data? If it is trained on the same data, it will learn the data, it will memorize the data. And what app is this? This is not an app, this is just like a annotation tool. You can get anyone from what do you call it, your Chrome store. Where did you study computer networks from? I have no idea. I don't know where I studied. I literally asked ChatGPT and learned it. Like, I have very less idea about that. And by where, how much depth should we study theoretical part? Very much. You should study this. Okay. The thing is that initially to crack interviews as well, but understanding the things as well, you should know this. Okay, so you can see I am giving you examples and telling you that now. So when you're working, you will see those examples in your work as well. So if you can't identify that, that would be really bad. Like I like, this is how a loss curve looks like. If you don't know how a loss curve looks, how can you know when to stop? Okay. Why do we need a validation set? So that we can like keep track. Is it learning or is it not? The hyperparameter tuning also depends a good amount of this. Models and test curves, what might have been the cause of? What would you do? How is the test set so good? What I feel like happened here is you have a data set, 80% was train and test, and 20% was validation, let's say. And they trained on the whole thing and tested on the same thing, but validation was different. So this is a very overfit model on this 80% data set. I think that is what happened. Okay. Again, open to interpretation. I'm not sure. What is the role? I have no idea. This is a very open role. They actually called me and said, "What do you want to interview about?" I said ML. They said okay. Like I think it is very open for that. And what are the things I'm going to prefer? That I'm not going to prefer anything. Okay. So this what you're seeing, I'm just doing this ML thing just as a public thing because so that like I don't have to do this once more. I can just see the video myself. And additionally, I also have like a small notebook of interviews. I'll just read that and go. I am not going to like usually. I don't think एक रात में पढ़ के कुछ होगा. It's maximum I can revise, nothing else. Okay. करते हैं question 6. 99% accuracy. Nah, this is overfit, man. This is overfit so much. First thing is overfit. Like if somebody says 99.99, you know there is some kind of shit, overfit shit is going on. Additionally, I think there might also be some class imbalance, like the data. Okay, class imbalance is something like this. You have some data which is huge and some data which is less. So, like for example, spam and not spam. If I have this, so if you know in base theorem, you'll have some PS into PS or whatever the message is by S. Okay, plus P of not spam plus P of message not spam. Okay. So since this is so much, this is 0.9 and this is like 0.99 and this is about 0.1, so 0.01. So the class imbalance is so huge. In majority cases, it will classify things as spam. I think that might have also happened here. One reason can be overfit. Second reason can be class imbalance, I guess. And I think another can be unfair practices, I guess. Unfair as in like training on the test set, I guess. Okay, so can be many things. Can't stop study DAA. How had you studied theory in detail? I used to read a lot of random shit. Okay, this paper I'm solving right now. No, this is see, I have not done theory in like a year. Last time I have studied theory was in December last week, I guess. So whatever I am doing is like out of fucking brain shit. Okay, so you have to learn like that. You have to see that on your daily basis. You have to learn how to how do I call it? How the things happen. Then you will not forget it. Can't study DSA. DSA, I start writing code. It's simplest thing. You will never forget it. If you start writing code, you will never forget it. Okay. Next question. What is F1? F1 is basically the harmonic mean of precision and recall. In simple thing. Okay. If you know harmonic mean is 1 by C is equal to 1 by B plus 1 by E. So here you put precision, recall, and F1 score. Okay. Can you use for more? Yeah, there are some things called macro F1, micro F1, I think so. I don't remember these too much extent. Okay. There were some terms like this, if I remember correctly. And you can easily do it from that. Important questions. So whatever questions I have don't exceed this is at least. This is very much detailed. Okay. Calculate the model's precision, and precision is what? True. I think true positive by all positive. True positive is what? 30 by 35. So whatever. This will be the precision. Recall is like the true shit, like TP by TP plus Fn. I think this was the formula, no? So TP is 30 plus a false negative is 20, no? False negative is 20. Yeah, it's 20. So it will be 3 by 5. And I think we have to find also the F1. F1 is what then? 1 by F1 is equal to 5 by 3 plus 7 by 5. 7 by 6, sorry. So this will be what? 1 by F1 is equal to 6 to 10 plus 7, f1 is equal to 6 by 17. I don't know if the calculation is correct. Please be vigilant. Please be vigilant. I don't know calculation is good. Yeah. How do I improve performance? How do I improve performance? Can you tell me? Recall is kinda low, to be honest. I mean, we have recall is low. That means what? We have less amount of positive values. So get more positive values is what I feel. I have no idea. The role that I have applied for is called intern, comma Cisco. I'm not even kidding. So they even told that it can be any role. So I have no idea. So they literally called me and asked what role are you more comfortable with. So I said ML specific. So they said okay. This is what their response was. So like I don't know. So like since I told ML, that's why I'm preparing for ML. As simple as that. I have forgotten half of this. Okay, so if you know, I am searching a lot here, as you can see. So just so that I remember this, I'm solving this. 90% many questions I cannot solve. Okay, if you have a classification 99% data balance, if one TP is 0, f1 will also be 0. Positive. Yeah, if the positive is like belonging to B, it will be 0%. If negative is belonging to Z, it will be 99.999 whatever percent. If you have a model that predicts B at random, what will be the expected f1? Yeah, so expected f1 would be something like randomly selected. It will be something about 50% is being selected. So whatever the Q value will be, let be a probability plus 0.5. So Q for B will be 0.01, I guess, no, 1%. Yeah, by 0.1. Calculate this value, man. I cannot calculate this. So 0.99 plus 0.5. So I think this will be the f1 value for the value of Q. So for example, this is for, I think this is for positive if the positive is considered to be B. If the positive is considered to be A, please consider this value, okay. Logistic regression wise, log loss recommended over MSE because log loss, I don't know why not log loss. What do they mean, like the cross entropy one, like this one? No, y log y minus, I think this was the formula, no, log 1 minus y. This is cross entropy, I think so. So the reason, no, plus, sorry. So the reason they do this is simple. Like you have this comes from the sigmoid function. Okay, this comes from the sigmoid function. The reason I feel like it's needed is that you have to do this. The sigmoid function has a cool thing of being broken into two parts, right? So I think this, because of this, maybe it's done. I don't know why would you otherwise think? It's a good question. Why didn't I think so? Is the question. Are you preparing for GATE? Yeah, I am. Like, I just filled the form. I'll go. No such preparation of sorts. When should we use RMSE over? RMSE is, it before averaging the values, it will square. So when there are like, yeah, if the error values, if it is more, don't use RMSE. Use RMSE, sorry, it will give you more shit. And MAE has like a very linear penalty, no? So not much sensitive, to be honest. No, much sensitive, sorry, but smaller sensitivity is not there. Is what I feel like the answer would be. I'm not sure about this as well. Show that cross entropy for binary. Yeah, it's the linear what do you call logistic regression wala proof. Okay, so logistic regression, what do you have it? The loss will be something y to the power, uh, I think it would be y, no, wait, so it would be yeah, so it is in the Bernoulli form. No, so Bernoulli form is what? So for, let's say, y cases, you have the probability p, and for 1 minus p, whatever, 1 minus y cases, so the loss will be p to the power y 1 minus p to the power 1 minus y. So, and log of L would be p log y plus 1 minus p log 1 minus y. So yeah, I think this is the definition. For the classification of more than two level, y cross entropy is a better. Again, I think these are all multi-class classification. They use softmax. Okay, so what happens is that yeah, so when you have softmax, right, so softmax is what? Softmax is, let's say you have some probabilities, you're getting like this probabilities, so you need to get it into 0 to 1. So that is why you apply. So these are the random values you get. Usually they are not in 0 to 1. So you want to make it a probabilistic distribution. So you apply softmax to it and you get this probabilistic distribution. And yeah, I think this is the main reason softmax is used. Okay, this is very good distillation paper mein. It's written very well. I'll show you. Wait. I don't remember where it is written, but it was written in this paper. I remember this. So I'll just copy paste this paper. It was written why we choose softmax. So why is softmax so good? I'll share this here. I don't remember which. Again, I have read it so long. Consider a language with alphabet 27 letter. What is the maximal entropy of this language? So what is entropy? What is entropy? Entropy is nothing but h of x summation of p log p minus. So this is what entropy is, right? And since it's uniformly distributed, right? Uniformly distributed. So every entropy will be what? Every entropy will be 1 by 27 and log of 1 by 27. So when you do this, this becomes log of 27. This is the answer. Not a hard question, to be honest. If you know the formula of entropy, it is very easy. If a lot of machine learning models aim to approximate how do I measure how close is that? It's something called KL divergence. So we use something. There are many things. There is JS. I forgot the name. Jensen-Shannon divergence as well. So KL divergence is something. The formula is this. So you write it like DKL PQ. I think summation of what do you call it? Summation of PX log of PX by QX. I don't know. Yeah, this is the formula. So, and there is there a minus at front? I forgot. No, there is no minus. Minus is only there for entropy. So this is for a discrete case. Again for continuous, just integrate this. Okay. So yeah, KL divergence is a very good way to do that. I'm bored, bro. I'm not doing MP versus MP. Suppose you have a stock, predicted price should not be more than offer. I have no idea. And stock shit I've never done in my life. So these two questions I will not answer right now. So let's go to this. Basic questions. So I'll just take a short break and come back soon. So give me like some time because I've been speaking for what, like around 45 minutes now. Okay, I'll take a short break and come.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. On we'll go, finding life along the way, melodies we haven't played. No, I don't want no rest, echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
I'm walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. Yeah. We are heroes tonight.
Hello, we back. I went to drink some water. Mm-mm-mm. Chalo. Let's try to solve, man. Linear regression, basic. I don't remember this shit at all. One thing is linearity, of course. The relationship between x and y will be linear. The it will be a IID, as an independent distribution, and the value of errors, right? So, for example, so I'll just write it down better, I guess. One is linearity. The second thing is the variance. I think SD of all the errors should be some constant value. The third would be the third. Bro, I don't remember this shit again. Yeah, independence, the IID, independent distributions. I don't remember. So this has like 7 points. Okay, this has 7 points. You have to memorize by heart if you're going for interviews. I remember only 3, so yeah. Please read it. What if we don't apply feature scaling to logistic regression? I think trailing will be very not converging. So basically, we have some gradient shit in there. No, so unscaled features will be like very out of range, or like I don't think that it will converge. If I'm not sure, it will not converge well. Is what I feel like is the case. But I'm bored about these classical ML questions. Let's just go to NLP, I guess. This is one thing I can understand a bit better, and I'm also very tired because I kinda did. So there says what, 15 questions. Okay, 15 question. Okay, let's try to solve this, bro. This is one question I can understand. I can answer. This thing I feel like I can get 15 out of 15. Okay, so if I don't, that's a shame. But I feel like wait a second, let me just answer to a text. Okay. Give me 2 minutes. Let me answer to one text. One important text has come up, so give me a second. Okay, I'm back, so let's do this. What is the motivation for RNNs? What is the motivation? What do you feel like is the motivation? So basically, it's mostly used for sequential data, like even in case of text, it will be very sequential. So it is a function. It is a function again. So it is a function of the earlier state, ht minus 1, and the current input. Okay. So I think the function kind of comes out to be like this is for the hidden state. Okay, so function is something like ht is equal to some function of omega ht minus 1 plus w x xt plus some bias. I think this is the forward pass for RNN, right? So the main thing is that we are propagating the recurrence thing, is that we are updating hidden states. Hidden states is like, if you unroll it, you can see it like open up. Like for example, usually an RNN is like this block that just goes like this, but if you unroll it, it looks like something like this. So let's say this is ht minus 1 goes here, we take our input xt, it gives you ht, and you go to ht, this gives you xt plus 1, then you get ht plus 1. So this is called unrolling an RNN. Okay, so you unroll this. Okay, this is the main motivation, this sequential event that depends on times. LSTMs is basically RNN but with a extra thing. So this thing, the main problem with RNN is simple. Okay, so the main problem with RNN is that it does not generate long context. So if you see, ht is only dependent on ht minus 1. Okay, so you get the context of the earlier one, and additionally when you do backprop as well, so as you know, in RNN you will have two weights, h of t, h of x, and I think you'll also have the output as well. So you'll have some output here, yt, so you'll have the weights for weight of output as well. So d of loss with respect to d of weight of output is very easy because it's just one step, right? But when you go do the with this h size, so dl of d, let's say ht, you can break it down to dl of d ht minus 1 d ht minus 1 by d of ht, right? And so on. You can break it down and it becomes like a whole chain, what do you call it, chain rule in differentiable. So this gradient becomes very small. So this problem is called vanishing gradients. Okay, vanishing gradient. So this vanishing, or it can become very big as well. If the values are greater than 1, it becomes very big. If it's less than 1, it becomes very small. Then it is called exploding gradients. So due to these two, not this issue, but due to the context thing, right? So because it only depends on ht minus 1, you add another line. This is called a long context. So LSTMs do what is that it maintains a long context. It has some one forget line. So I don't remember the detailed formula. LSTM had a very big formula. It forgets some things, it adds some things, and rest of the things is exactly same as RNN. There is no difference to RNNs from LSTMs. Okay. How would you do dropouts? I won't. I'm just kidding. So you would usually do dropouts in the non-recurrent correction. So whenever, let's say, the input, the output, these are not the recurrent things, right? You apply the dropout to this shit, but don't do it on the HT stuff, because hidden state dropouts, you will lose the continuity is what I feel like. So don't do that. What is density estimation? Density estimation, you can like tell language models because a language model will be given some words and it predicts the most probable next word, right? So it evaluates, you can say it evaluates like likelihoods of tokens perspectively. So they are probability density estimators. I think that is a reasoning one can easily form from this. Unsupervised learning or tail mechanism is different from supervised learning. It looks like supervised, to be honest, but you don't have labels perspectively, right? You don't have labels. For language models, usually you try to predict the next token from like any text. So yeah, this is more of like you're applying softmax function at the end. So I think more of it's not supervised, that is straight, because supervised learning, you have fucking things, you have like, if this was the case that I tell it that this is the next, it would be it would be supervised. Okay, why do we need word embeddings? I would say word embeddings are needed for two reasons. Okay, we usually used to have one hot vectors, right? So let's say this is apple, bat, like this is a very inefficient thing because you have like 50k words. It's inefficient. So what you do is that you get some feature vectors or vectors perspectively, which also have a summation of pi is equal to 1 again. for 50k. So you represent this 50k using a vector. Simple. If you plot, let's say if it's a 3D vector, you can plot it. Let's say this word is here, this word is here. So even in Word2Vec, you can do something like this. Very cool thing. So for example, let's say king is here. This is man. Sorry, man would be very close to king, right? Sorry, man is here. And let's say woman is here. So how do we find the feature vector for queen? What you do is very simple. So if you see, if you strip the value of king minus man, you get royalty, and if you just add woman, you get the value of queen. This is very like logically, humanly logical, right? So what I can do is that I'll get this. So king plus king minus man. So you have to just do man in the reverse way. And king versus man is something, is in this direction, right? And when you add woman plus this value, you get this vector approximately here, approximately queen. So you see the queen vector is very close to woman, which is again the case for king and man as well. So our logic for having a word embedding is really strong. Okay. Any comments? Let me check. I don't think there will be much comments. Count based. Count based is I think that glove, no? And prediction based is the Word2Vec. I said Skipgram, Seabao. So they try to learn embeddings by a model. While count based is something like how many times is it appearing. For example, I think glove works on that only. Glove is like that. You don't train a model. Problems. Context based word embedding में problem. What is the problem? I might say like opposite words will be together, like hot and cold will be used in the same context, but they are different shit, na. So I think in that case it will be a problem. If you have very less amount of data, that will be also a problem. You don't know where to put it, like a very weird disease name maybe. So yeah, this can be two problems, I guess. So TF IDF, very good sum. I think next one is TF IDF, no? Okay. 15 questions to go. Let's go. So DF is basically document frequency, how many times this is appearing. So the early bird gets the worm, so the early bird gets the one. So you have to find the DF for each of them. So the early bird gets the worm. The appears 1, 2. Should we consider bird? Usually we don't consider the things, but okay, as it was, let's do the early appears 1, 2. The will not count the because it's like useless. Early appears 1, 2, 3. I hope so it does not appear there, bro, because I don't want to scroll this much. Yeah, it does not appear. So like 3, so on you calculate for the other things. I cannot. And inverse document is basically, I think it was this formula, log of total documents, like 5 by df. So you put this value, you get inverse value, you multiply it, you get TF IDF. Okay. So yeah, cosine similarity again is very easy. Just query, change the, you'll get a vector for each of this. No, you'll get a vector. So like for example, let's say if you have duck will have a 5 vector, and TF IDF will also have a 5 vector. Do a cosine similarity means dot product, means as in I think cosine similarity is this, no? A dot b by mod A mod b. Was that the formula for cosine similarity? I forgot. Hope I am not wrong. Wait, cosine similarity. I have forgotten so many formulas. Images. Yeah, it's correct. Good that I have not flunked this. You got into game theory? No, I was interested yesterday, but I have an interview, so I have to study for this. I am not interested to answer this big question right now because I have to solve the question, otherwise, I'll not know this answer. Client wants to train a language model. The data set is very small at 10,000. Would you use an Ngram model in neural things? Neural LM with 10k tokens is very less. I will surely like overfit on that data. Okay, but Ngram models, I don't know, will not be much better, but it will be better than using a neural LM. Okay, so next question is simply, if I increase n, will model performance increase or not? I think so. There is some trade-off here. The graph for this will, I think, for the graph for n versus performance will be something like this. It will plateau at some point and go down again. So yeah, there will be some peak. I think you can just experiment this. This is a very important question. Like, yeah. I feel like that is something that will happen just because it will initially it will underfit, then it will overfit. Is what I feel like will happen. That is my concept. What problems might one occur at softmax as the last layer, and how do we fix it? Yeah, I think for very big token size softmax is a problem because it will take for per token, it will check all vocab, no? So yeah. How to fix it is, there are many types of softmax like you can learn. Okay, there is something called a hierarchical softmax, which kind of calculates softmax in a tree based manner. I don't remember this that much. This is called hierarchical. This takes O log V. Earlier you had to just go for all the vocabulary, na? So it has to be OV. So OV to O log V. Okay. We also do this in OS, by the way, when you do paging, right? So you have a page table, you have to traverse the whole thing in the worst case. So this is O of n. But what you do is that you break this page table into a tree format like this. Let's say 3 level, right? So this becomes O of log n, because maximum what you have to try, you have to go the height of this tree, right? Height of the tree. How do we find the height of the tree? Let's say, the last element will be n by 2k, 3 by k equal to 1. So k is value is log 2n. So this is how hierarchical shit works. You can do negative sampling as well. That is also one thing. I can do many things for that, to be honest. What is the Levenshtein distance between bottle and I think Levenshtein, I'll do it later. It's basically DP. It's 2D DP, dynamic programming. If you have learnt it, it's basically 2D DP. I have to see that. Blue is a command. What is the pros and cons of? Pros is very fast. It's very fast, by the way. Okay, and you don't need to know the language. You just need to know what tokens are there. Shit is it is very, for if you have very less amount of samples, it's very shit. Okay, and does not understand your semantics of the text very well. Okay, so, and I think blue with respect, CHRF is better. Okay, CHRF is the character level, and for blue, I think if you have also seen for human samples versus like human evaluation versus blue, and human evaluation versus CHRF, higher CHRF gives a good and human evaluation checks are very similar. But in the case of blue, we have seen कि sometimes it's good, sometimes it's bad, depends on the scenario. Okay, Lewis-Time distance reduce on the same test. LM has a character level entropy of 2 LM model. Which model would you choose to deploy? Okay. One is like bits per character, one is bits per word. So, 5 characters words we have, so we have a 10 bit per word. Again, you have to have the same unit. I feel like these are not the same units. The comparison is useless. So you kind of find out the average word length and convert the character to the word, or find out the average word character length, like character levels words, and do like bring them to the same unit and then compare is what I feel like. What's the next question? NER model on the text website with you make it sensitive? Yes. Because in NER model, if I say I had an apple, I bought an Apple phone. This capitalization means it's a company, and this small letter means it's an object maybe. Okay. So in NER, I think, yeah, you need to make it case sensitive, okay, because it will help you a lot. Does removing stop word sometimes help sentiment? Yes. Like I love no one. So in the thing, this will become love one, right? No is a stop word, by the way. So yeah, inverts the meaning. So I think don't do stop word shit with sentiment analysis models if the sentences are small. It won't hurt you. Many models use relative positional embedding and absolute positional embedding. What do you absolute is basically the sine cos sinusoidal one. I don't know about relative. Relative, I have no idea that much. Don't have much idea about relative one. Relative, I think, would help you a lot because they will like generalize the sequence a lot. Like for example, how to explain this? Like relative, rather than keeping like first में I होगा, last में I होगा, depends on the scenario, they will change the positional embeddings. Is what I feel like. And with long context as well, I think relative will help a lot. Some same widths for both embedding layer and the layer just before softmax. What is the purpose of this? So if you have the same input embeddings and the output embeddings, so you don't need to like okay, you can have less parameters but the same level shit. Okay, so you're saving a bit on the parameter things, and yeah, and if you do that, what will happen is that whatever the input is, it will encourage the output to be closer to the input. Okay, so yeah, I feel so. Okay. Give me 1 minute. I'll try to solve the Lewis-Time ones, and I think we'll call it quits today after that. I don't remember the Lewis-Time ones. So basically it was like, for example, this is doctor and bottle. Na? So you have to write like doctor, bottle, and it was some 2D DP sum. Like you have to insert, there is one thing called insert, delete and replace, and there were 3 DP states for this, and you have to fill this table. This is like this table, and I don't remember this correctly, to be honest. And then whatever the minimum value was to be, minimum of DP, minimum of DP ij would be your answer to this. Okay, so this thing, Levenshtein distance thing, is actually used in autocorrect. Okay, I did study that earlier, but I don't remember it right now. So yeah, I think we'll end it here only, or should we do one more section? Like, I can do it if I'm free. I cannot do reinforcement learning and CV because I don't think they'll ask that much. Bro, 30 questions. Can I do 30 questions? I am not in the mood to do 30 questions. What is other? I can try some of these, bro. Autoencoder tries to copy input. Like when you, like image generation, I guess. For example, let's say if you have image of yourself, right? So, and if you're trying to say generate the image of yourself, so yeah, you get a vector for yourself, then decode yourself to yourself. I think in these cases it will be better. What is the motivation for self-attention? Very simple logic. Why? So in the case of sequence to sequence, let's say this is a RNN. This is RNN. This is the decoder. This is the encoder. You had a single context vectors for this, and you had a single context vector for decoding this. So the same thing that what they did was simply, you have a RNN, not a problem, encoder, decoder. You put for the first hidden state or the first block, first token, whatever you say, put it through, I think the first layer was a softmax. Put it through a softmax, generate a context vector Ci. With the help of that, you generate this. So for every token, you have a different context vectors. So better with context. So yeah, answers this as well. Why would you need a multi-headed attention instead of one? Wait. So I think I'll answer only 3. I'll only answer 3. I cannot answer all 5, I guess. GANs I have not studied that much, to be honest. GANs last time I have removed that from my CV as well. Okay, so yeah. So the main reason we use multi-head attention is that when you have like many attention heads, right? So this is, let's say, 3 attention heads. So what do you get? You get these are all squares. So n into n, right? So n into n, you have 3 n into n's. You stack them together. So what does this become? This becomes the column size is increasing, row into column, right? So this will be n into 3n, right? So you get a weight matrix of 3n into n. You multiply that with that and you get n into n multi-headed attention. The reason is that this will get some features, this will get some features, this will get some features. As many heads you have, you get more features out of the words and better results as well, is what I feel. The number of heads affect the model's performance. So yeah, if you have more heads, then you will have more partitioning of like the whatever the total subspace or like total dimension is. You'll have better subspaces. Few heads, you will have bigger subsets. And yeah, again, too many heads will break it into subsets that don't have any meaning. Okay, so you have to find the best. Usually 12 works fine. Transfer learning, you freeze most of the layers and you fine tune the top layers. Okay, gradual unfreezing is the same. Gradual unfreezing is the same thing, but gradually start unfreezing some of the things, and I will not do the rest. See, GAN, I don't remember that much. GAN is basically you have like a model, generator model, enable discriminator model. So simply what happens, you have a real image. It goes into the GAN. Wait, let me just erase this. This is the generator. This is the discriminator. You have a real you tell the GAN to generate an image of, let's say, a cat. It generates an image of a cat. I don't know how to draw a cat. You put it into the discriminator and you put a real image of a cat, real cat, and it tells, is it same, is this fake or not. If when and then it updates the loss accordingly. Okay, so you have a discriminator loss, you have a generator loss, and it tries to minimize that. I think they GAN uses the Jensen-Shannon divergence for this. I'm not sure again. The J is divergence for this, and then finally whenever the discriminator cannot differentiate between the cat and the thing, you stop and you get a good cat. So you get that generator is the good one. As simple as that. I think that this is enough for an interview, I guess. I don't need anything else. If I still don't get it, that's it. Chalo guys, bye bye. Love you all.